Alright, so I was watching a proof video and I have the proof to the following question over here. As you can see, I have a proof to Purple Minds. Let's calculate the pi in the strangest way possible. This video, you can see the link here. If you haven't watched this video yet, watch it. It has to do with matchsticks and their orientation. And if I go back here and show you here, here's the way the proof works. So this will be our matchstick, right? So the first thing to notice is our matchstick, right? The matchstick has to land. It doesn't matter, first of all, it doesn't matter like vertically where this lands, right? It doesn't matter if it lands here, it lands here, it lands here. It doesn't matter, right? The math is still the same because the parallel lines go on forever. So it doesn't matter where it lands vertically, but like horizontally, it does matter where the match lands. So we'll call this is a match has to have two ends, as we know. So we'll color this end red. This red end must land some distance away from one of these two lines, right? This red thing must land some distance away from one of these two lines, right? If it's pointing this way, it must land somewhere along here. And if it's pointing the other way, like if it's pointing this way, then it must, then since there's an infinite number of parallel lines, then again it must be some distance away from that line. So because it's symmetric, we can also exclude that probability. So we can narrow it down to our match end must land some random distance away from this line that is between 0 and the length of the match, with all of which with equal probability, since the match is thrown at random. So its ends land in random places. So now what we have to do is we have to calculate the average of all the possible scenarios of where the match ends. What is the probability that its line intersects here? Now, if you notice something here, right? Let's say, for instance, that the match lands here, right? The end lands here. We don't know where the line is. We want to see what is the probability that it will intersect this line, as we already narrowed it down to the match has to point right. So now for this line, right, as you can see here, we know the match stick must land, there are 180 degrees, or in this semicircle there's 180 degrees, or pi radians. And all of these possible orientations have equal probability. Since this is symmetric, we only need to consider the ones above here. So we only need to consider this area of possible areas it can land. Sorry. Let me fit. We only need to consider this possible area. We only need to consider the 1/4 of the quadrant, which is basically that this possibility here. Of all possible orientations in this quadrant, we only care about this since it's a symmetric problem, right? So the match has equal probability to point in any direction here inside the red circle. Red quarter circle. Now, the chance that it intersects with this line, given we know the start position, we'll say the start position between a number between 0 and 1. Let's say the match is 1 unit long. X% away from here, right? We know the distance here is X away, right? From the red dot, the horizontal distance between X and here is X away, right? Now, under what circumstances is our line going to be inside here? Well, we know that if the angle, here's the angle, right? What we need to find is we need to find the critical point, which is basically at what point, what is the maximum this angle can get before the match is no longer touching the line. And it turns out that maximum angle is arc cosine of x. The reason why is because the max angle happens because arc cosine is calculated going counterclockwise starting from the horizontal, right? So it's starting from going here. So that means that for our line to intersect, right, the angle has to be smaller than this. And what the arc cosine function is given the horizontal distance, given the adjacent side from this angle here, theta, right? Given the adjacent side of theta length, what is the angle? Given that the hypotenuse of the triangle, right triangle here is 1. And that is why it's arc cosine x. Now what we need to do to find the probability of a stick thrown at any random point, with the n being at any random point between these two lines, is we just need to simply integrate the arc cosine between 0 and 1. We just need to integrate, average everything out to see what the probability of the stick intersecting with a line is. And I actually did it over here. I shared it with everybody here. We have, so blah, blah, blah. I talked about this already. So now we represent it with this integral. You can see arc cosine x is the possible angles that that we are successfully intersecting the line, divided by all possible ways our stick can point, which is 1/2 pi, and then this is actually known what the integral of arc cosine is. We solve for it here, and then we integrate from 0 to 1, and then eventually after some simplifying, we find our answer is 2/pi. Therefore, we have shown and proven directly that the probability that the match lands on a line is equal to 2 divided by pi. And that is the proof for Purple Minds video. You can access it. I put a link here. I'm going to be commenting a link here in the description of the video if you want to see the document. But there you go.